Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the fourth part of the series of CSIR NET Physics June November 2020 paper solutions. Okay, so also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so this is the fourth part of the series of CSIR NET Physics June November 2020 PYQ solutions. Okay, so I'm going to start with first question of the day. The question is, a basket consists of consists of an infinite number of an infinite number of red and black balls in the proportion P ratio 1 minus P. 3 balls are drawn. 3 balls are drawn at random. Without replacement. The probability of there two red and one black is maximum. For options are option A, P equal to 3 by 4, option B, P equal to 3 by 5, option C is P equal to half, and option D is P equal to 2 by 3. Okay, so this is the question guys. I'll solve it for you. Question is a basket. So a basket consists of an infinite number of red and black balls. Okay, so there are infinite number of red and black balls in the basket in proportion, and their proportion is given. Okay, in proportion P ratio 1 minus P. Okay, so this is the proportional ratio. Okay, for red and black balls. The three balls are drawn randomly from that basket. Okay, the probability of there being the probability of there being two red and one black is maximum. So the probability of there being two red and one black, okay, is maximum for. So we need to find that maximum probability. Okay, explain this. I'll solve it now. So first we'll find probability. Okay, proportion is given, so probability is going to be P. I'll write in next. I'll solve in next page. Okay, so probability P is going to be, because proportion is given, guys. Okay, this is basket consists of infinite number of red and black balls in proportion P and 1 minus P ratio 1 minus P. Okay, so for red ball is P and for black ball is 1 minus P. Okay, so 2 red ball means we can say P into P. Okay, so because proportion is given. Okay, the proportion. Okay, so 2 red ball and the probability of 2 red ball and 1 black ball means the proportion of 1 red ball is 1 red ball is 1 minus 2, right? So my apology, that is black ball. Okay, for red ball it's two red ball are drawn, right? So P into P and this 1 minus P. Okay, this is the probability. Okay, because proportion their proportion is in their proportion is given. Okay, so if you solve this is going to be this P square into 1 minus P. That is the probability. Okay, now small. Okay, okay. Okay, so now what we have to find out, that is the probability for there being 2 red 1 black is maximum. So when it will be maximum? For maximum minima we know, right? This is the probability. Then for maximum value of P. Okay, for maximum value dP upon d small p is going to be 0, right? That is for maximum value, right? Okay, so now what we'll do, we'll differentiate it. So this is going to be d upon dp into p square into 1 minus p. Okay, that is equal to 0. So we'll differentiate. We'll use product rule. So this is going to be first function. Differentiation of second is minus 1. Okay, then second function, and differentiation of first is 2p equal to 0. Okay, so this is going to be minus p square and this plus 2p minus 2p square is going to be 0. So this is 3p square minus 3p square plus 2p equal to 0. So from here 3p square is going to be equal to 2p, and pp will get cancelled. So value of p is going to be 2 by 3. Okay, 2 by 3. Okay, so this is the answer, guys. 2 by 3. Which option is matching? 2 by 3 means option D is matching. Okay, so the probability of there being 2 red and 1 black is maximum for which value? For p equal to this. For p equal to 2 by 3, the probability of getting 2 red ball and 1 black ball will be maximum. Okay, so very good question, guys. There there are infinite balls. Okay, and we have been given their proportion. Okay, so we'll get the probability first. So probability means because the proportion is p ratio 1 minus p, right? So there are 2 red ball means p into p square, and 1 black ball means 1 minus p. Okay, so this will be probability. For maximum value of probability, we know that dp upon dp is going to be 0, and then we'll solve it and we'll find the value of p, right? For this value, the probability of getting 2 red ball and 1 black ball is going to be maximum. Very good question, guys. I hope you have understood it. Okay, next question, question number 2. Meanwhile, let me check whether I'm audible or not. Second function and differentiation of first is 2. Yes, I'm audible, so I'll proceed further. Now, question 2 is, these are very good question, and these are the questions of 2020 physics CSIR NET paper. Okay, so next question is, this is also a good question. It is matrix question, which I have already explained in my lecture, mathematical lecture. Okay, so question is, the eigenvalues of 3 cross 3 eigenvalues of the 3 cross 3 matrix, eigenvalues of 3 cross 3 matrix M, and matrix M is given. Okay, so this is A square, AB and AC, AB, B square, BC, AC, BC and C cube. Okay, so this is the matrix, and eigenvalues of 3 cross 3 matrix, this M, R. Okay, so eigenvalue of this matrix we have to find out, and options are given. Options are number A square plus B square plus C square, comma 0, comma 0. Okay, option B is B square plus C square, comma A square, comma 0. Okay, option C is A square plus B square, comma C square, comma 0, and option D is A square plus C square, comma B square, comma 0. Okay. Okay, so this is the question, guys. Okay, okay, so very good question, guys. Very simple one. So I have already explained this question. So we have to find the just eigenvalues of this matrix. Okay, and these are the options which are given. So we have been given M, value of M equal to A square, B square, BC. Okay, and then AC, BC and C square. Okay, so these are the options. Okay, So this question I'm going to solve by trick, guys. I have already explained this trick in my mathematical physics lecture. You can check it, okay? So trick is, this is not trick and this is the rule actually, okay? So, okay, so this is if we can, if we can, this is matrix property actually, okay? If we can mm, write, we can write columns or and rows or columns. So rows or columns. If we can write rows and columns of matrix as scalar, scalar multiple, scalar multi, scalar multiple of any rows or column, any row or column, then eigen eigenvalues of the matrix is trace comma 0 comma 0, okay? If we can write rows or columns of matrix, okay, rows or columns of matrix as a scalar multiple of any row or column, then eigenvalues of matrix is trace comma 0 0, okay? Trace means sum of diagonal elements. So this matrix we can write the scalar multiple of rows and column, okay? I'll show you how. Okay, so very important property you need to note down, okay? I have already explained in my lecture of mathematical physics. So the, the matrix is this, okay? So I'm writing this matrix. So M is a square into 1 ab. I'm showing you how I can write, okay? ab into 1 ac a square into 1 a square into 1 ab into 1 and ac into 1. And this one you can write ab ac b square bc ab ac b square bc and bc c square bc c square, okay? This we can write like this. This is the function, right? So we can write this one into a square into a up. This is, wait guys, so this one, okay? So I'll show you this ab, this one ab. A square this one A square AB A square AB. I'll show you guys. Okay, AC, and this we can write A square A square AB and AC. Okay, so we can write this one. The first term is AB. AB means B upon A into B upon A into B upon A. This is AC. AC means AC. C upon A into C upon A into C upon A. Okay. See, this is the any row. Okay. So this statement, if we can write rows or column of matrix as a scalar multiple of any row or column, then eigenvalues of the matrix is trace 0 0, right? Matrix R. Okay. So you can see that this is the value, right? AB. If you solve it, this one will get the same value. Okay, this one A square AB AC, and this is A will get cancelled. This is AB and this is B square. Okay, and this is BC. If we solve this, right, A will get cancelled, BC, and BC, and then this one is going to be AC and BC and C square. Okay, so look at the same matrix. Okay, C square base, right? So we can write this matrix as a scalar multiple of any rows and column, right? This one. So it means the eigenvalues of M are trace comma 0 comma 0, right? So the eigenvalues are going to be, trace means sum of diagonal element, right? This is A square plus B square plus C square. These are the diagonal elements, right? So A square plus B square plus C square comma 0 comma 0. Okay, so this is the answer, guys. This is the answer. Okay, so which option is matching, guys? Option A. Option A is matching. Okay, option A. Okay, so very simple, right? We are able to write this eigenvalues directly because we can write this matrix as a scalar multiple of any rows or column. So we have written this matrix as a scalar multiple of this column. Okay, first column, right? So this is the answer, guys. I hope, guys, you have got the point. Now next question, guys. Okay, next question is question number 3. Okay, question number 3 is, it is also very good question, guys. A function of a complex variable, a function of a complex variable, z is defined by defined by the integral defined by the integral fz equal to closed integration gamma w square minus 2 upon w minus z. Okay, this is the function given dw, where this gamma sign, okay, where this sign, okay, this gamma sign is a circular contour, circular contour, circular contour of radius 3, of radius 3, centered at origin, centered at origin, centered at origin, running counterclockwise, running counterclockwise, running counterclockwise, counterclockwise in the w plane, in the w plane. The value of the function, the value of the value of the function, value of the function at z equal to 2 minus I. Okay, z value is 2 minus I is, okay. Options are given. Option number A 0, option number B 1 minus 4I, and option C 8 pi plus 2 pi I, okay, and option D is minus 2 upon pi minus iota upon 2 pi. Okay, so this is the question. So I'll read it for you. So a function of a complex variable z is defined by integral fz equal to this, okay, and this sign gamma is a circular contour of radius 3, okay, centered at origin, running counterclockwise means this is anti-clockwise, okay, in w plane. The value of function you need to find out, okay. Very good question. I'll solve for you. So first we'll make a circle, contour circle, right? This is a circle, guys, which is centered at origin, okay, whose radius is 3. This radius is 3, and this is in w plane, okay, w plane, okay. This is the contour, okay, and we have to find out the integral value of this, okay, fz, integral value of fz, okay. This is the contour in w plane. Okay, now I'll solve it. This value is 3, okay, 0 3 comma 0, okay, these are 0 0, okay. So now since we have been given fz value is given, closed contour integration, closed contour integration, contour is circle, okay, closed contour integration, closed contour integration, w square minus 2 upon w minus z dw, okay. So this is the fw is given, right? So now for pole, we'll find for pole, for pole, for pole, w minus z equal to 0, so it is in w plane, okay. So value of w is z, okay. So w equal to z, okay, which is a simple pole, right? So it's a simple pole, so residue, will find the residue. So residue at z equal to, z value is given, z value is given, okay, 2 minus I, 2 minus I, this one 2 minus I. Okay, so this we need to find out. So residue at z equal to 2 minus I. So we'll write, we know how to find that. Okay, so this is going to be limit z tends to 0, okay, w minus z, because it's a simple pole, into w square minus 2, w square minus 2, this is 2 guys, not z. Okay, w square minus 2 upon w minus z. Okay, this we know how to find the residue, right? Very simple, and I have explained it in my mathematical physics lecture. In mathematical physics lecture, guys, 32 lectures has been completed. So in next 4 or 5 lectures, mathematical physics is going to be completed, guys. Okay, so you can watch that as well. These two value got cancelled. Okay, and now so limit z tends to 0 means we can add the value. Z value is 2 minus I, right? That is given. 2 minus I tends to 0, and we'll put the value. So this is w square minus z. W square minus z means 2 minus I whole square minus 2. My apologies. W square minus 2, right? So we have put the value of z. Okay, here z value is given, right? Since z is given, z is 2 minus I. So we have put it, and so this value is going to be 2 minus I tends to 0, and so this value is going to be not 0, guys, my apologies. So this is made mistake. So this is w tends to z. Okay, this is w tends to z. Okay, and this is going to be w tends to 2 minus I. Okay, so we have put the value. So this value is going to be 2 square plus I square. We are opening it at whole square. Okay, minus 4I minus 2. Okay, so this is going to be 4 minus 1. Okay, I square value is minus 1 minus 4I minus 2. Okay, so this value is going to be this minus 3, so this is going to be 1 minus 4I. This is the residue at w equal to z, right? Or w equal to that value, 2 minus I. Okay, so 1 minus 4, so this value is 1 minus 4I. Okay, now this you can also see, we can see here this one, w equal to z means z value is 2 minus I. Okay, 2 minus I means this is the contour. Okay, imaginary contour or w plane, and this is real axis, this is imaginary axis, right? 2I means this point will be somewhere here, right? Here in x-axis 2 and in y-axis minus 1, right? This is minus 1. This point is the coordinate of this point is 2 minus 1, right? In imaginary axis, right? This is I-axis, right? So you can see that this point, this point is, because it's the radius of this contour is 3, right? And this is 2. This is inside, and this is minus 1, right? So this is inside these 2 minus I. So 2 minus I is, that is the point is 2 minus 1, right? This is inside this contour, right? It means the residue is going to be so this, it means the value of this integration is going to be value of this integration, closed contour integration, w square minus 2 upon w minus z. Okay, dz dw, apology, dw, this value is going to be this value is going to be 2 pi I into sum of residue, right? Sum of residue. sum of residue. So this is 2 pi I. Residue at z equal to w equal to z is this one, 2 pi I into 1 minus 4. Okay, so this value is going to be 2 pi I minus 8 pi. This is 4i, right? That's why minus 8 pi. This is going to plus 8 pi. How? Iota will get will be multiplied, and that is going to be iota square. Iota square value is minus 1 plus this is 8 pi. Okay, so this is the answer, guys. Which option is matching? 2 pi I plus 8 pi. So which option is matching? The option is option C is matching, right? Option C is the correct option. Option C, 2 pi I plus 8 pi. Okay, or we can say this one, 8 pi plus 2 pi I. Okay, so this is the answer, guys. So this is the question number 3rd. Now we are going to solve question number 4. Okay, question number 4. It's also a good question, guys. Question number 4 is the temperatures of two perfect black bodies. The temperatures of two perfect black bodies of two perfect black bodies two perfect black bodies A and B are 400 Kelvin and 200 Kelvin. Okay, 200 Kelvin respectively. If the surface area of A, if the surface area of A is twice that of B, the ratio of total power emitted by A to that by B is. Okay, options are given. Option A is 4, option B is 2, option C is 32, and option D is 16. Okay, 16. Okay, so this is the one. So question is the temperatures of two black bodies. Okay, temperatures of two perfect black bodies. Okay, two perfect black bodies A and B are 400 Kelvin. Okay, 400 Kelvin and 200 Kelvin. Okay, these are the temperature of perfect black body. Okay, we know what is the perfect black body, right? Which emits and absorbs complete energy, right? Respectively. And if the surface area of A that surface area of black body A is twice that of B. Okay, then the ratio of power emitted by A to that of B or to that by B is, okay. That's what we need to find out. Very good question and very simple question, formula based question, guys. Okay, and I'll solve it for you. So here I'll tell you. Okay, so here first we know the temperature of A that is given. Okay, temperature of A is 400 Kelvin and temperature of black body B is 200 Kelvin, right? And here we know the we know here this relation, guys, and that is energy density U is proportional to T to the power 4, right? That we know, okay, by Stephen's law. So this is U is proportional to T to the power 4, right? This is what we know, okay. So this means UA means the energy density. This is energy density, okay. UA means the energy density of black body A, okay. So this is we can write UA upon UB, because this is very important, right? Okay. UA upon UB equal to, this is going to be T1 to the power 4 upon T to the power 4, right? When UA is the energy density of black body A, UB is the energy density of black body B, T1 is the temperature of black body A, and T2 is the temperature of black body B, or we can write TA TB, okay, TA TB. So this is going to be, we can write UA upon UV, energy density of A upon energy density of B is T4 means 400 Kelvin to the power 4 upon 200 Kelvin to the power 4, right? So there are 0, 0, right? We can if this is the case, we can write like this. Simple calculation, 0, 0 will be we can remove that. So this is going to be 4 to the power 4 upon 2 to the power 4. Okay, because it is 400 or it is 200. 400 upon 200, right? So this is means 4 to the power 4 means, okay. So now we'll solve this further. So 4 times 4 and then this, and this is going to be 16. This value is going to be 16, okay. 4 into 4 into 4 4 times, and 2 into 2 into 2 into 2 4 times, okay. So this value is going to give 16, okay. So this is the ratio of UA upon UV, okay, equation number 1. Now we know here, this is important, okay, power. So energy density, we know that energy density is power, that is energy emitted per unit time per unit area, right? And that is or we can write this one, and also we can write this, energy density is energy emitted per unit time per unit area, right, from the surface. Or we can write energy per time is power. I am denoting power by P, okay, power upon A. So from here this implies power is equal to UA, means energy density into surface area, right? So from here we can get this one, the PA upon PV is going to be power emitted by black body, power of black body A upon power of black body B. PA upon PB is going to be equal to This is UA upon UB into A. This is A1 upon A2 we can write, right? A1 is surface area of black body A and surface area of black body B. Okay, so this is going to be UA upon UB. We know we have already found that is 16, right? So this is going to be 16, and A1 value is in question it is given. The surface area of A is twice that of B. Okay, so surface area of A is 2A upon A, right? Surface area is twice of surface area of A1 is twice of that surface area of B. Suppose the surface of area of B is A, then surface of area is going to be 2A. A will get cancelled, so this is going to be 32. So it means PA, it means PA upon PB equal to 32. PA upon PB equal to 32. So this is the answer. 32. This is the answer. Okay. Okay guys, so this is the answer. So which option is matching? Very good question. Option C. Option C is matching. Okay. Next question guys, and this question is from thermodynamics. Okay. Next question is question number 5. Question number 5 is, this is also good question. Two ideal gases two ideal gases in a box two ideal gases in a box are initially separated by a partition okay. Let N1 V1 and N2 V2 be the numbers of particles and volume occupied by the two systems when the partition is removed when the partition is removed the pressure of the mixture at the equilibrium at an equilibrium temperature T is okay. Options are option number A, that is KT. K is Boltzmann constant. Okay, KT into N1 plus N2 upon 2v1 plus v2. Okay, this is the option A. Option B is kt n1 plus n2 upon v1 plus v2. Okay, and option C is kt n1 upon v1 plus n2 upon v2, and option D is half kt n1 v1 plus n2 v2. Okay, this is the question. Well, so very good question, guys, from thermodynamics. Two ideal gases in a box are initially separated by partition. Okay, so there are two ideal gases in the box. Okay, which are separated by a partition wall. Okay, and n1 v1 and n2 v2 be the numbers of particles and volumes occupied by the two system. Okay, and when this partition is removed, we have removed the partition, the pressure of the mixer at equilibrium temperature T we need to find out. Okay, so I'll solve it now. So we have been given this is the condition, guys. Okay, this is the box, and there are two gases. Okay, 1 and 2. Okay, and n1 v1 is given, number of particle, and number of n2 v2 volume is given. Okay, let this is p1 as well, p2. Okay, so this is given, and now what happened is we have removed this wall and this partition, and then this will mix with each other, right? And at equilibrium temperature T we need to find out the final pressure. Okay, so that is the question, guys. So we have to find the pressure of the mixer at equilibrium. Okay, so very simple. What we need to do is, we know that formula, right? PV equal to gas equation, right? PV equal to nRT. Okay, this we know, very important formula. Okay, so here we can do P, let at equilibrium temperature, let pressure is P and volumes are V1 plus V2. So we can write P V1 plus V2 equal to nRT, right? We can write this there at equilibrium temperature. Okay, the pressure at, I'll write pressure at equilibrium temperature after mixture. Okay, equilibrium temperature. The pressure at equilibrium temperature. Okay, so P V1 plus V2 equal to nRT. Okay, P V1 plus V2 equal to nRT, and now we need to find out these values, right? P so from here, value of pressure at pressure at equilibrium temperature. Okay, P is going to be nRT upon V1 plus V2, right? Now we'll find the value of this is equation 1, value of n and then we'll get the required equation. Okay, so n means n1 plus n2, because there are two gases, right? The mixture of two gases, so n is the total mixture, right? So n is going to be a mixture of two gases, and since we know n equal to number of particle upon Na, Na is the Avogadro number, right? So this is going to be, we can write n1, so so there are n1 particle in first part, right? N upon Na plus n2 upon Na, we can write it. Okay, so these are very important formulas you need to note down. Okay, so this value is going to be n1 plus n2 upon Na, right? And now we know, since we know this one, Boltzmann constant K is equal to R upon Na. right? This also we know, this is also the Boltzmann constant is R upon Na. Okay, R upon Na, this is the Boltzmann constant. This is also very important formula, guys, you need to note down. Okay, so now what instead of n we can write it, right? So if you put this value in equation 1, this equation upon Na, I will get the number. Okay, this is Na into RT upon V1 plus V2, right? Na upon R value is K, right? So we can write value of T is going to be this value is n R upon Na, this R upon Na is K, so Kt into this value is going to be Kt into N1 plus N2, N1 plus N2 upon V1 plus V2, right? V1 plus V2. Okay, so this is the answer, guys. Kt into N1 plus N2 upon V1 plus V2. So this is the answer, guys. So which option is matching, guys? Let me check. Kt into N1 plus N2 upon V1 plus V2. So option B is matching, guys. Okay, so option B is the correct option. Option B is the correct option. Okay, Kt upon N1 plus N2 upon V1 V2. Okay, very simple question, guys. So we know the gas equation PV equal to nRT for ideal gas, right? So for at the pressure at equilibrium temperature, when it gets mixed, this is going to be P, total volume. Total pressure is P and total volume is going to be V1 plus V2 equal to nRT. nR, there are two mixture of two gases, right? So n is n we know, right? Number of this is n value is this one, guys. This n value is n is the number of moles. Okay, number of moles, and that is n upon Na. Number of atoms upon or number of particles upon Avogadro number. Okay, and here also we know this formula, guys. This one n equal to n upon Na. Okay, number of particle upon Avogadro number, and value of Boltzmann constant is R upon Na. Okay, so we have done put this value and we've got the required answer. Okay, next question, guys. Question number 6. Question number 6. Okay, question number 6 is, this is also a good question, guys. This is from statistical physics. Okay, this question is, the question number 6 is, okay, an idealized atom, an idealized atom, an idealized atom. Okay, so idealized atom, ideal atom we are talking about. Okay, idealized atom has, very good question, a non-degenerate, a non-degenerate, an idealized atom has a non-degenerate, idealized atom has a non-degenerate ground state, non-degenerate ground state, non-degenerate ground state. Okay, non-degenerate ground state at zero energy, whose energy is zero, at zero energy. Okay, at zero energy, at zero energy, and a G fold, and a G fold means whose degeneracy is G. Okay, G fold degenerate and G fold degenerate, G fold degenerate, excited state, excited state, excited state of energy, of energy, of energy E. Okay, of energy, of energy E in a non-interacting system, in a in a non-interacting system non-interacting system of n such atom n n such atom n such atoms in a non-interacting system of n such atoms. So there's a n such atom, there's a system of n such atoms which is non-interacting. Okay, the population of excited state, the population of the population of the population the population of population of the population of the excited state population of the excited state population of the excited state may exceed population of excited state may exceed that of the ground state 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 okay, above a temperature T greater equal to E, above a temperature T greater equal to E upon 2K. K is the Boltzmann constant, okay, 2K ln, K is the Boltzmann constant, okay, 2K ln 2, okay, and the minimum value of the minimum value of G, minimum value of G for which minimum value of G for which this is possible, for which this is possible is okay. Options are: option A is 8, option B is 4, option C is 2, option D is 1. Okay, so this is the question, guys. I'll read the question for you. Okay, the question is: an idealized atom, okay, an idealized atom has a non-degenerate ground state. So idealized atom has a non-degenerate ground state at 0 energy, okay, and G-fold degenerate excited state, okay, of energy E in a non-interacting system of n such atoms. Okay, there is a system of n such atoms which is non-interacting. Okay, the population of excited state, okay, the number of atoms in excited state may be greater than that of ground state, okay, above the temperature, when the temperature is above or more than E upon 2K ln 2. Okay, the minimum, okay, right, now we need to find the minimum value of G for which this is possible. Okay, so minimum value of G for which this is possible, that's what you need to find out. Very good question. I'll solve it for you now. Okay, so we have been given two energy levels. Okay, this one, this is ground state we have been given, whose energy is 0. That's what we have been given, and there are, suppose, n1 particle, okay, in ground state. So there is G-fold degenerate excited state. D-fold degenerate excited state means the degeneracy G is G given, okay, G-fold means the degeneracy G is given this, and energy is given E. okay, for excited state. Okay, let there are n1 particle, and in here there are n2 particle. Okay, so we have to find that this temperature T greater or equal to this E upon 2k ln 2k ln, right? The population of excited state may exceed the that of ground state. Well, so now I'm going to solve it. Okay, so now we'll find first partition function. Okay, partition function P1 for partition function for the particle which are in the ground state. Okay, so partition function P1 is going to be, we know, right, partition function formula sigma I gi e to the power minus beta ei, right? This we know. This is the partition function, that is P. Okay, so here we'll find P1 for n1 particle. So this is going to be, degeneracy is 1, right? Energy is 0. So this is going to be 1 into partition function means Z. We'll find Z. This is Z, guys, not P1. This is Z. Okay, so we'll find the partition function. The partition function is going to be Z into sigma I gi, right? For ground state it is going to be 1 into e to the power minus beta into 0 plus gi means sigma gi, right? So this is G, degeneracy of excited state is G, because it's a G fold degenerate state, right? So G into e to the power minus beta e, value is E, right? So this is Z is going to be 1 plus G e to the power minus beta e. Okay, now we'll find probability. We'll find probability for ground state. Okay, so this is going to be P1. P1 is going to be very simple, that probability for ground state is going to be this one, this value, this value means this partition function at 0, beta equal to 0, right? This value upon the partition function. So this is going to be e to the power minus beta 0, right? This one. E to the power beta 0 1 into, right, upon partition function Z. So this is going to be 1 upon Z, because e to the power beta 0 means e to the power 0, that value is 1. And P2 is going to be partition function for P2, that excited state. This is ground state, right? Excited state is going to be G into e to the power minus beta e upon Z. So this is going to be G e to the power minus beta e upon Z. Okay, this is the partition function here. Sorry, probability P1 for ground state and excited state P2. Okay, so now we know this formula which we need to find out. So number of particle in ground state is going to be total number of particles, total number of atoms into P1. Okay, and similarly N2 is going to be total number of particle into P2. This is very important formula, guys, you need to note down. Okay, so from here we'll find N1. So N1 value is going to be, number of particle N1 is going to be this one, N into P1. P1 value is 1 upon Z, so into 1 upon Z. Okay, and N2 is going to be that N into P2 value is G e to the power minus beta e upon Z. Okay, this is the one. Okay, so this is the one. So we need to find this one, the population of excited state, okay, may exceed that of ground state above the temperature this. Okay, and then the minimum value of G for which this is possible. So minimum value of G we need to find. Okay, so these are the first. So for minimum value of G, okay, for minimum value of G, N1 is going to be equal to into Okay, so this means n into 1 upon z equal to 1 upon this one, n into g e to the power, yeah, n into g e to the power minus beta I upon z. So this is z, right? Z will get cancelled and n will get cancelled. Okay. So this is g e to the power minus beta I is going to be 1. Or we can write value of g equal to this will go in right with this side, right? 1 upon e to the power minus beta I, or we can write e to the power minus plus 1. So this will be e to the power beta I. E to the power beta I means beta values 1 upon kt, right? K is Boltzmann constant, so we can write e to the power e upon kt. Okay, now temperature value will put at for minimum value of g, n1 is going to be equal to n. Okay, so we'll put this, so this is going to be e to the power e upon k t value we know, right? T value is this one, t is this given, this one, we'll put this at t equal to e upon 2k ln 2. Okay, so this is going to be e upon 2k ln 2. k will get cancelled, e will get cancelled. Okay, so g is going to be e to the power ln 2 power 2, right? This will be 2 ln 2, and by log property 2 to the power 2, right? And this value we know ln e means 1, right? And this is 2 to the power 2, so this value is going to be 4. Okay, so 4 is the correct answer, guys. So it means, so minimum value of the g for which this is possible is 4. Okay, so which option is matching, guys? Option B is matching. Okay, option B is matching. Well, I hope, guys, you have understood it. Okay, so very good question, guys, this one. Okay, so for that, what we have done, we have learned new thing is this partition function we know, right? And this one, n1 equal to this is n1 equal to np1. Okay, total number of atom into probability for ground state, and n2 equal to np2, right? And for minimum value of g, n1 will be equal to n2, and at t equal to, we'll put this value e upon 2k ln 2. Okay, so we'll get the required answer. Okay, guys, so before ending the class, I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, guys, thank you so much. Bye now.